For multiplying radicals, we start with a product rule that we use for radicals. So assuming they have the same index, both square root, both cube root, we can take a product or multiplying two separate radicals and put them within one radical. So something like the square root of 2 times the square root of 3, we make into the square root of 6. Now, be careful, they again have to have the same index. Square root of 2 times the cube root of 3 isn't going to be 6. That's not going to work. We don't want to fall for that. Most times that wouldn't come up, but we just want to be careful. Now, if I happen to have coefficients in front of the radicals, if I say a root b times c root d, I'm going to put the two coefficients out in front, multiply those together. Those are my rational terms within this. And then b and d are the irrational. They're going to be multiplied together. So something like 5 root 2 times 7 root 3, I should multiply that correctly. 5 times 7 would give me 35. 2 times 3 would give me the square root of 6. If I could simplify that further, I would, but that condenses them together. So now we start putting some stuff with some variables and terms. I'm going to put the coefficients out in front first, so that's 10. Then I have 6x to the 4th and 8x to the 5th. I like putting them all within one radical because as opposed to addition and subtraction where we have to simplify them separately, these don't have to match perfectly. We just push them into one radical and then simplify. So if I look at it a little bit more, 6 times 8 and then x to the 9th. I could multiply 6 times 8 together and get a number, but if I'm simplifying the radical, I have to then take that back apart. It's kind of already started been taken apart. 6 is 3 times 2, 8 is 2 times 4, and then 4 is 2 and 2. So if I'm looking for sets, I have the 2's here, those are going to come out, 3 is going to be left over. So I'm going to go 10 times 2 on the outside, 3 stays inside. X to the 9th in a square root, if I have 9 x's, and I'm looking for sets of 2, I can make 4 of them, so that's x to the 4th, 1x left inside. The last thing we do is put it all together. We have 10, 2 and 2 gives me 40, x to the 4th, square root of 3x. Important thing there is combine them to one radical, then simplify the radical. Now, we might come across something that at first looks like addition, or subtraction in this case. Sometimes we want to think of order of operations and simplify inside the radical first. Unfortunately, we can't do that in this scenario, and that's why we're going to use distributive property. Now, the distributive property you've learned before is if you have a times a quantity of b plus c, you multiply a to both terms, which looks like this. So we're going to take square root of 10 and multiply it to both. So we got square root of 10 times 5 root 5 minus the square root of 10 times 2 root 2. This becomes 5 root 50 minus 2 root 20. Now they're not like denominators, so I can't, or like radicals, so I can't combine them. 20. So I need to simplify. Now 50 is 25 times 2, which gives me a pair of 5s. So that 5 comes out, multiplied to the 5 on the outside to make this 25 root 2. 20 though is 4 times 5, which gives me a pair of 2's. The 2's come out to be multiplied by the other 2, and I get 4 root 5. Now from here, I have to go back to what I talked about in addition subtraction. These are not the same, so I can't combine them. That just makes this our simplified answer. It doesn't solve it. It did leave it as a subtraction problem, but what we're required to do here is multiply the radicals and still simplify, and that's really the bigger goal. So as we move to some other ones, 3 root 10 times 2 root 18. I'm going to put 3 and 2 in front, make that 6, and then that's 10 times 18. Sometimes we want to multiply that to be 180, but then if you have to go in and simplify it, you're back at 18 times 10. So I'm just going to leave them separate. 18 is 2 times 9, and that 9 gives me a set of 3's. I got this 2 floating here. I could get another 2 from the 10, which gives me a pair of 2's. So now I have 6 times the 2 coming out times the 3 with the 5 left over. 6 times 2 is 12, times 3 is 36, so my answer is 36 root 5. Now we go to 4th root of 64 minus 4th root of 8. Again, I'm going to put these both together. Why do I have a subtraction there? This actually should be multiplication. I'm going to put these both together and make it 64 times 8. I'm not going to multiply them because I want to take them apart. Now, 64 is 8 times 8. Because of this, I can look and say, well, I got 3 8s. Unfortunately, it's 4th root, and that doesn't make a set. I have to keep going down. So I got 4 and 2, which gives me 2 and 2. 4 and 2, which gives me 2 and 2. 4 and 2, which gives me 2 and 2. I got a lot of 2's there. So this is actually 3 times the 4th root of 3, 6, 9 2's. So I'm going to rewrite that as an exponent. So it's the 4th root of 2 to the 9th. The 9 is the exponent. It tells me I'm going to have 2 sets. Again, if I have 9 2's, there's a set, there's a set, I'm going to have 1 left over. So 3 times 2 comes out. We're left with the 4th root of 2. We then put our terms together. 3 times 2 is 12. We get 12 4th root 2. For our next one, 2 and 5 are going to come together to be 10. I then have the cube root of 9 times 24. Now 9, if I'm looking for cube root, gives me 2 3's. I'm going to get another 3 from the 24, which also then gives me an 8, which if we know our cube roots is going to give me a 2. So I have a set of 2's and a set of 3's. So it becomes 10 times 3 times 2, and our answer is 60. We've got rid of the radical entirely and we simplified our answer. Now we bring in some variables. So before I start simplifying, I'm going to put it all under 1. So 3 times 36, a to the 7th, a squared gives me a to the 9th, and then I have b to the 6th from b to the 4th and b squared. Now, I got this 3 here. If I could get some more 3's, it would help me. So if I divided that by 3, I get 12. Divide it by 3 again, I get 4. That gives me my set of 3's that are going to come out, and then the 4 is left inside. 4 being 2 times 2. It's not going to have 3 2's there. A to the 9th, if sets of 3's, is going to take 3 out. B to the 6th sets of 3 is going to take 2 out. So my answer, which pretty much is right here, but I'll rewrite it together, is 3 a to the 3rd b squared cube root 4. Next problem, I'm going to multiply 2 and 7, which gives me 14. And then I have the 4th root of, that's p squared and p to the 3rd is 5 of them, and q to the 11th. 14's done, it's taken care of. I don't have any number to simplify. I'm just going to figure out what sets of variables I can take out. P to the 5th with a 4th root, I have 5 of them. I can take out 1 set, leave 1 on the inside. Q to the 11th, if I'm looking for 4's, 1, 2, with 3 left over. So q squared comes out, q to the 3rd left over. So we'd say 14 pq squared, 4th root of pq to the 3rd. Our last problem, we have to look at simplifying. Now, I have square root of 12k, and I have the square root of 15k squared. I could work with this one and make it, bring out a k and make it minus 2k square root of 15, but it's looking like we're not going to be able to simplify on the inside by using addition or subtraction. They don't have the same exponents, they don't have the same radicals. So I'm going to use the distributive property and multiply that to both of them. So in multiplying the square root of 3k to the square root of 12k, I get the square root of 36k squared. To the other one, I have 2k on the outside, and on the inside, 45k. Now I'm going to simplify them separately to see if I can combine them. Square root of 36k squared, well that's 6 and 6, so a 6 comes out, k squared in the square root becomes k. 45 is 9 and 5, which gives me a set of 3's. Those come out with the 2 to make it 6k square root 5k. Now, that is the variable and radical part, and that's the variable part. They don't match, so I can't put them together, but this is just going to be my simplified answer, 6k minus 6k root 5k. It's a simplify down, see if they can combine, but really the big question is, can you simplify radicals?